Here for I3. I3 is equal to 1.75 minus 2.75 times 0.391. Now, if you keep the fraction instead of going with the decimal, then you are not introducing any rounding errors at this point, but it happens.
I got 0.675 amperes.
0.675 amperes. So I3, 0.675 amperes. And I1, well, I know I1's just the sum of those two. So that would be 6. Then 6, carry the 1, 1.066. Anyone else thinking a little Norman Conquest right now? 1066.
That's funny.
If you have no idea what the Norman Conquest has to do with 1066, look it up. Not now.
I enjoy that.
All right, any questions on this before we do math technique number 2?
Can you pause for like 5 seconds?
We probably should check our answer.
Should we? Don't you trust childhood?
Oh, you're trusting that I did put a minus sign in the wrong spot?
Oh, shoot.
I believe, I appreciate the great faith that you have.
I trust you. What is it?
Well, we could check it just by doing a different technique and see if we get the same answers. If it's not the same answer, then the question is, do we make the mistake here with that which I'm about to erase, or make the mistake the second time?
You're absolutely right.
Let's just believe in ourselves. We did it right. Questions or any other need for me to pause before I erase? Jabez? Ampere, the unit for current. I'm going to highlight those decimal points there. All right, math technique number 2. Having done this bit for a number of years now, I just want to apologize. There is absolutely no way to make this exciting. It is pretty, here's the technique, and it is what it is. It doesn't make it less important, it just makes it less exciting. So math technique number 2, solving simultaneously. So what I want to do is I want to get them sort of lined up. I'm going to rewrite these equations so that all my I1s together and I2s are in a line, I3s are in a line, and non-I's are in the other line. So for the first equation, I'm going to take these two right here and just move them to the other side. So I have 4I1 plus 7I2 equals 7. The next equation, I'm going to bring the 4 over. So I have 7I2 minus 10I3 equals -4. And the last equation, I have I1 minus I2 minus I3 equals 0. So I've just rewritten the equations. They should still be what we had before, just rearranged. That's technique number 3. Technically, we're going to use a determinant. Solving it using matrices is another technique which some people might employ, but I'm not going to go through inverse matrices and multiplication of matrices. Now I have to figure out what I'm going to get rid of. So first thing I'm going to do is I'm going to get rid of I2. So I'm going to combine these two equations. What I'm going to do is I'm going to take the first equation, we'll just call this equation 1. This is equation 2 and equation 3. So I'm going to do equation 1 minus equation 2. So I end up with 4, not an equal sign there. So 4I1, 7I2 minus 7I2 is 0. I have 0 minus negative 10I3, so this becomes plus 10I3 equals 7 minus negative 4, which is 11. So it's just a matter of subtracting for those, let me rewrite that just for those who missed what I was doing there. Plus 7I2 equals 7, and then 7I2 minus 10I3 equals negative 4. And all I did was I subtracted this. So 4 minus 0 is 4I1, 7I2 minus 7I2 is 0, 0 minus negative 10I3 is 10I3, and then 7 minus negative 4 is 11.
Do you mind if we use zeros as like placeholders when we're writing this ourselves, just to
Plus 0I3,
get that?
and then 0I1.
Okay, so that's okay.
Yeah, there's absolutely no problem sticking a plus 0 in there.
Cool.
For the third technique, you definitely need the zeros in there.
Okay.
All right. Now I got rid of I2 there. I need to get rid of I2 using a different combination. So what I'm going to do is I'm going to use, let's just say, the first and the third one. Now I have I2 here and I have 7I2 here. So what I have to do is I have to multiply this bottom equation by 7. So what I'm going to do is I'm going to do the first equation. So 4I1 plus 7I2 plus 0I3 equals 7. And then I'm going to do 7 times the third equation. So 7I1 minus 7I2 minus 7I3 equals 0. Technically 7 times 0. And now, because my I2s are opposite signs already, I'm just going to add these two equations together. So I have 11I1 minus 7I3 equals 7. I've now reduced it down to two equations, two unknowns. I have this equation here, and I have this equation here. I'm going to call this equation 4, and this equation 5.
I'm sorry, so we're adding that one instead of subtracting?
Right, because here they were the same sign already, so I had to subtract it to get rid of it. Here they're already opposite signs, so I'm just going to add to get rid of it.
Oh.
Other questions at this point? All right, so I now have these two equations here. I'll just rewrite them. So 4I1 plus 10I3 equals 11. And 11I1 minus 7I3 equals 7. I want to combine them so that I get rid of an unknown. My I3s are already opposite signs. It's just my eccentricity. So I'm going to multiply this equation, top equation by 7 and the bottom equation by 10. Because that is going to give me coefficients that are the same here. So I've just multiplied them by the other coefficient. So this becomes 28I1 plus 70I3 equals 77. And down here, 110I1 minus 70I3 equals 70. I add these together now. So 138 what's I1? I1 equals 147. I1 is 147. over 138, which is a little bit more than 1, which is what I'm expecting. I feel like we got off somewhere, but
1.065.
recognize it is slightly different than what we had before. That could be that we're off just a little bit, or it's just a different rounding place. Because that over there involved rounding what we did before, and we didn't really round here at all. Define I2 or I3. Well, actually finding I3 might be the next thing to do. Well, we have an equation right here. Just plug in. I know that 11 times I1, which is 1.065, minus 7 times I3 equals 7. And it looks like about 0.675. It'd be nice to actually check that, but it will be positive. So roughly 4/7.
Also for the slight difference between this one and the first technique. In the first technique, I kept everything in fractions, and it ended up being 48 over 46, which is what the 147 over 138 simplified.
They're both divisible by 3?
Yeah.
Okay. All right.
So it works.
And so I3, so that makes me feel better. And then to solve for I2, well, pick an equation, doesn't really matter which one. Since we know I1 and I3 at this point, any of them will do. Or choose all 3 and see if you get the same answer. Again, it's one of those double-edged swords. We can pick all 3 of them, solve for I2. If we get the same answer or close to the same answer every single time, we should feel pretty good we've done something right. If we get something different, then you now have a decision to make on a quiz or test about whether how much time you're willing to spend to try to figure out if you have a minus sign in the wrong spot. All right, technique number 3. There's no possible way we can do it in the remaining 5 minutes, and I want to hand some stuff back. How many of you have dealt with determinants before? 3 of you. 4. Okay. We're basically just doing 3x3 determinants or 2x2 determinants. We're not getting any more than that. Most of your calculators will do determinants if you know how to use it.
Dr.
Yes.
Why did you multiply on the I3 equation by the 7 to 10?
Here?
Yeah.
All right, I was going to get rid of my I3s. And so I knew if I multiplied that by 7 and that by 10, just flipping the numbers, that they would end up with 70 and negative 70, and that when I added them together they would cancel out. Now, I do want to comment on the quiz or test. When you're solving this, some of you will have calculators that you know how to use, and you will use a calculator to solve it. Just recognize if you're using a calculator to solve this, so you get the 3 equations, and then all of a sudden you have calculator work, and then you have answers. There is no partial credit in that for that part right there, because I have no idea if you mistyped something or what happened. So just, if you're going to do that, check your answers, or just take a leap of faith. On the conceptual questions lab that we did, the biggest issue people had was only giving part of an answer. You know, like the induction. Most of you got something close to it, but you left off bringing a negative charge, a positive charged object near a neutral object will polarize it, but that doesn't charge it. And so you need some other source in order to actually pull electrons onto it and then break the connection so that the electrons have no place to go but stay. So you're basically drawing electrons. So if I have two metal objects here and I bring a positive charge near it, it's going to draw the electrons from both charges onto here. Then if I remove this one, this still has all the negative charges on it, then now this is charged. And so a number of you got bring it, something positive or something negative to draw electrons to it, but it didn't, you sort of left off at that point. And that seemed to be a common thing. So Benjamin, Michaela, Anna, Brenda. There's half the group right there. Ben Johnson, Jabez, Chow, Devin. Katie, Carly, Janice. Ian, Jalissa, Aaron, Sarah. And now the master sets. Now we got a couple more grades in. At this point, none of you can get better than an A, and none of you can do worse than an F. So congratulations on narrowing it down from an A to F. Ciao. Carly. Being in here is going to be a Monday thing. Yeah, that's a Monday thing. So Wednesday, Friday, we're still in the other room. Answers to the master set are up here. I don't have a nice form. I thought, why don't I just post it since everybody's done it? But here's an ugly form of it.
So, are you gonna put something on there?
I need to write it up more neatly, or I guess I could potentially just scan this and hopefully you can pull out what you can. There's a higher priority is I need to do the solution set for master set for another class. And